Thank you for joining us today on the webinar using generative AI for evidence-based academic research. This webinar is brought to you by IES Research Insights. As you might know, IES is a team helping researchers to improve research efficiency via smart tools and boost research visibility while engaging videos and global outreach. Together with Cite, a smart tool leveraging 1.2 billion of citation statements and artificial intelligence to boost efficiency and accuracy in academic research, we will use this 1 hour to take a deeper look into the best ways for students and researchers to use AI in their article discovery, literature review, and finding answers for academic questions. My name is Iris Chu, consultant at IES Research, and your host for the webinar. So today we will have Dominic Rosati, head of AI at Cite, as our speaker. Dominic received a Master of Information from Dalhousie University, where he investigated natural language processing applications to bibliometrics. His current research interests are natural language understanding of scientific texts. After Don's sharing, we will wrap up with an Q&A session, and you are encouraged to ask any questions during the session by typing them in the chat box or using the Q&A button. Now, without further ado, let me pass the floor to Dominic, and let's start with sharing.
Hi there. So yes, I'm going to be talking about using generative AI for research tasks, going over what generative AI is, and just, yes, you're welcome to ask questions in the chat as the presentation goes, and depending on the intensity of the question, I may save it for the end, but I'm aiming to leave a lot of space for questions at the end. So that's kind of how this talk's going to work. So what we're going to be talking about today is generative AI. What is it? You've probably heard of ChatGPT and things like this and large language models. And really what we're going to be talking about is the emerging opportunities for generative AI for research tasks, specifically for text-related tasks that researchers have. So things that traditionally would have been taken up by traditional academic tools like discovery tools, search, literature review, and so on, and manuscript writing. Then we're going to go do an overview basically of the landscape of generative AI tools that are being explored for different research tasks, including a new generative AI tool that we're developing at Cite. And then, I think a lot of people who have some exposure to generative AI, especially in the research and academic spheres, are aware of some of the major issues with generative AI. So those are important to touch on, like fraud, factuality, and quality. And then I'll show a little bit about Cite Assistant, which is our generative AI research tool that we've developed at Cite to illustrate how we might resolve some of those issues. So what is generative AI? Generative AI models are capable of generating artifacts like text and images. Current approaches to generative AI and natural language generate text using large language models. This wasn't always the case. There's been text generation for many decades now, but it's really the power of large language models that have given us this ability to use a single model as a single interface for doing all kinds of different tasks without training that model specifically for that task. And so large language models are just models which have been trained to predict the next word in a sequence of words on a very large corpus of text which happens to be a large fraction of text on the web and a large portion of scientific literature that's open and available on the web. So these models do have some familiarity with research text, which is why they're able to be used in research tasks. So this is just what generative AI looks like. If you have used generative AI in any capacity, you'll recognize this. It's the ChatGPT interface. And so there's like several sort of leading GPT style models with interfaces that are familiar to the public, like ChatGPT, Google's Bard, Anthropic's Claude, and Bing Chat, which is unique among these. Bard and Bing Chat because they are what are called grounded generative AI, meaning that they ground their generations in retrieved search results. So why that's important is because when we have a normal, previous sort of generation of generative AI like ChatGPT, we have generated text like this. So this is just a question pulled from the BioAsk biomedical question answering data set. I am not a biomedical researcher. I'm an NLP researcher, so I don't really know, how to read and comprehend this, but here's just a classic question in biomedical, a question answering what disease is caused by de novo VPS4A mutations, and an answer from ChatGPT. And we'll return to this answer, but some things should be clear to you, clear differences to you as researchers from what you would normally see in a human-generated answer of research quality and academic rigor. And that is that this answer has no citations. Without being a domain expert, and even being a domain expert, but say in cell biology or clinician, we might not have any familiarity specifically with this mutation. And so we really don't know whether this is a good answer. Is it the right answer? Is it a made up answer? And so on. So before we talk about how generative AI for research, we should look at the traditional research tooling setup that scholars typically use. And so these are just a few of the tasks that a scholar might use, the ones that are maybe generic across disciplines. So these are tasks like literature discovery and literature review. These might be search with Google Scholar, Semantic Scholar, something like that, or an academic literature database, synthesis tools, like a systematic review tool, or tools that provide synthesis of literature, reference management tools like Zotero. We have question answering, which typically is done through search. So we might use Google search for answering questions while we're doing research. For instance, questions about protocol design, statistical methods, and so on. There's a question about will the slides and videos be made available. I'm not sure if it's being recorded, but certainly I'll send my slides over. Do I close that? Yeah. So typically as scholars for answering questions, like for instance, how does a certain method work? We might look at reference books and so on. For summarization, typically we're looking at abstracts, right? As the author produced summary or survey papers. For writing assistance, even this, it's not so much an assistant. We have Overly for Google Docs for typesetting. We have manual review, reading our manuscripts out loud. to detect if there's errors. And then, of course, we have peer review, both for writing assistance and for criticism. Now, for generative AI for research, we can use a interface much like I showed you with ChatGPT and do all of the same kinds of tasks in sort of like a command style or a chat style way of using the model. So this would be, instead of, coming up with search terms yourself for literature discovery, you could just ask the model, find sources that discuss topic X. For question answering, you can literally ask the model, what is Y? How does protocol Z work? Explain this to me, and so on. For summarization, again, it's all about using the input carefully to prompt the model, to ask the model to follow some kind of task. And so we can have that with summarization, we can have that with writing assistance, criticism, and so on. So generative AI allows researchers to turn many of their day-to-day tasks and activities into prompts that the generative AI models are capable of accomplishing. And so there is emerging literature breaking down each of these tasks, really showing their efficacy in research tasks. And kind of what the advantage of using a generative AI interface for doing all of these tasks is that you can sort of stay in one tool and have a natural language conversation almost with the model, accomplishing all of your research tasks that normally would require 5 or 6 tools in your workflow. So it's a way of streamlining your workflow to be able to use one single tool. And of course, there's many different discipline-specific tasks, but there's literature showing, again, efficacy that on these tasks in generative AI for discipline-specific tasks. So these might be things like experimental design and social sciences, clinical tasks like care plans and prognosis, protocol design for life sciences, material sciences, and so on, proof assistance, code writing, statistics assistance, and so on. And we're sort of staying in the realm of text tasks, but there are emerging models that I won't go over, but GPT-4 is sort of one among them, where we can start to look at tasks that require processing of images. So this might be the production of figures, for instance, from a table of numbers. Or another example is the analysis of radiology image or something like that. So I'm going to go over, and I've been neglecting checking the QA. Okay, no further questions. I'm going to go over the sort of existing generative AI research tool landscape that are specifically tailored towards, in different ways, scientific tasks, and explore them a little bit, explore kind of their weaknesses, so you can get a sense of like what they're capable of currently and what the big gaps are. So most of these tools actually are task specific at the moment. So for instance, Perplexity really is for search. Consensus and Elicit are both really only for question answering. Scholarly for summarization, right? GenAI for writing assistance. And there's many of these tools that are emerging as well that I don't have on here. But one kind of major difference between these tools and, say, Bing or ChatGPT is that other than not being tailored for scientific research or research tasks in particular, is that they don't support all tasks. So they're task-specific tools. So here's Consensus, which is a platform that does question answering, like I said. It also provides, so the way it does question answering is it retrieves claims from scientific abstracts and provides a summary over those scientific abstracts if you turn on the synthesize, and that's generated. And they also have a consensus meter. So they measure how many of the claims in a paper might, be positive towards a certain question or negative towards a certain question. Now, one thing that recently people have raised about a consensus is that, especially with like the consensus algorithm that they're using, is that it's still a work in progress, and there's issues like reversal of causation. So here's like some humorous examples, not to pick on them, because any kind of consensus measurement by large language models would be could be vulnerable to this without verification, or a separate verification mechanism. But the examples are: does cancer cause smoking? Yes. Does death cause car accidents? Yes. Does mood improve sunlight? I wish that one was true. How long is this session? It's until oh gosh, I'm not sure your time zone. It isn't till the end of this hour. So moving on to Elicit. Elicit is another question answering platform, which does a number of things. And even there are some task specific other ways of formulating tasks, like asking questions in documents and so on, that Elicit supports. But again, it answers questions by interrogating several papers and breaking questions down into sub-questions and summarizing all of those answers to sub-questions up to craft these answer summaries, to provide things like abstract summaries that are related to your question, and a number of other things. For instance, one thing that Elicit's really good at, which I not showing here, is that you can create a table where the columns are supposed to be information that you want to extract from papers. So say you want, interventions and outcomes, or sort of results and methods or something like that. And so you can ask a question or even type in a traditional search query and get a table of papers, and Elicit will extract the results and the methods, or the interventions and the outcomes and the populations, if that was the way you designed the table. The one kind of major drawback with Elicit, though, is it has very limited scientific paper coverage. It's mostly only abstracts with some open access full text. And so it does have a limitation there, on top of being limited to only question answering. Perplexity is one emerging tool that I'm putting in here. It's not specifically tailored to scientific question answering. It is what's called grounded question answering, or self-supporting question answering. But it's interesting in the toolkit for researchers because it does draw on web available resources, and many papers and other scientific resources, credible scientific resources, are available on the web. So it does pick up on a number of those. You can see, for instance, I'm not sure about ASH publications, but at least 2, 3, 4, and 5 are all from publications. I believe the NIH one will be from PubMed. So there's a question. Oh, thank you. And so Perplexity is more of a look at what next generation search engines might look like. And just I'll take a moment to discuss next generation search engines. So with generative AI, we have an opportunity when we do search or ask questions. So you can use Perplexity again with traditional search queries. Not only to show a list of results like you would receive in Google or Google Scholar for that matter, but also sort of a synthesis of those. So the generative part is generating this summary or this answer according to those results. But unfortunately, Perplexity, the one issue with Perplexity is that there's not really a good way to understand why these particular results were used. Here you do see snippets, but those snippets are just the first number of characters from like the website. So, we're not quite sure what was used by the model to when it cited these. We don't know the credibility of these resources. Of course, like we can see Cell, something from Science Direct, something from NIH, but we're not quite sure what these might be. So from Cell, like we can pretty easily infer they're probably scientific papers, but from Science Direct, is this a chapter? Is it a preprint? From NIH? We have no idea. Again, what is ASH publications? GenAI is another type of tool that's a little bit different. It is a writing assistance tool. So this is sort of like a different flavor of generative AI where we're not exactly using search, not exactly using question answering or summarization, but instead, as we're writing, we get these writing suggestions that are generated from a generative AI model. Actually, we work with GenAI at site to provide citations for these generated statements. However, one thing that you should be critical of is the citation process is kind of backwards. Really, it's providing citations for the generated text after the text has been generated, and people have their different opinions about how good or bad of a practice this is. Forget about generative AI in their own writing process themselves, whether post hoc citation is a good or bad thing. Regardless, what this means for writing assistance is that when this text is being generated, it's not being generated in regard to these citations. So it's not grounded in those citations, which is problematic when you want to have high quality scientific literature that's grounded in other literature. And so I'll go over Site Assistant more, but Site Assistant is a tool we're building at site, which really is the intention of it is to consolidate all of these different types of tasks that we might want to do with research tools. So search, writing assistance, summarization, question answering, and so on, into a single interface, and have those answers be grounded in scientific literature and verified both automatically, so we're not having any citations that are made up, we're not having any citations that don't support the text that's being generated. And finally, a very important thing is that users can verify why the model used those sources to generate the text, what's the quality of the document, and so on. And so, and because of how Cite works, which I'll sort of explain a little bit more detail later, we're drawing from over 179 million papers, including from over 60 million full texts. So this uses sort of like a full text search engine under the hood to generate these answers, or do summaries or find sources and so on. And so I want to go over some of the major issues that are still, there's still a lot of research being done about these. These are emerging issues with generative AI in general and generative AI for research in particular. Most of these will probably be familiar with you, for you, but some of these are fraud. So one big concern with especially people in administrative positions or teaching positions in academic institutions is that students are handing in work now that are not created themselves. They're created either in assistance with some of these tools, like ChatGPT, for instance, or created wholeheartedly, completely with ChatGPT, with almost no involvement from the student. There's also scientific integrity and fraud issues with researchers fabricating or using these tools uncritically, and that ends up that there are entire papers that are fabricated, or sections, which the outcome of that is fabricated results. And related to the next point of factuality, which is that without a system that grounds these models in retrieved results and verifies the output, these models are well known to make up facts and make up references, which I'll show an example of in a second. The final point is more subtle, but it's important for you to understand when you're thinking about the usage of generative AI in your own workflow, and that's quality. So the oversight of generative AI is actually quite hard because these models are so fluent. They produce text that's looks right. The verification of whether indeed they are actually correct, whether responses are correct, is hard. If you've ever read any kind of scientific work or research work outside of your own discipline, then you are familiar with this problem that the verification of text written by experts outside of your domain, or even in your own discipline, but with a method maybe that you're unfamiliar with or something like that, is quite hard. And there's a longer question. Well, let me see if I can fit it into what it seems. Okay, I'll get to this question in a second. Yeah, well, I'll discuss Site Assistant a little bit more, and I'll touch on this question. Okay, so for going back to major issues with generative AI for research, Okay, so there is, and here's an example of what I mean by oversight or quality. I mean, this touches on factuality as well. And if you use this in a paper fraud, which disease is caused by de novo VPS4A mutations have been, so saying these mutations have been implicated in a disorder known as spastic paraplegia type 60. Okay, so the problem here though is SPG 60 exists, de novo VPS4A mutations exist, but there's no record of SPG 60 being caused by VPS4A de novo mutations. So this is like a completely fabricated answer, and the problem, you can see sort of the problem keeps on going, because I can get the model to write an entire essay about the role of VPS4A on SPG 60, and it generates like a whole essay that's sort of cut off here. And I can also, and this is ChatGPT again, and I also can ask it to provide references for the above essay, and it provides a bunch of references, but actually only the only references that actually exist are 2 and 5. The rest of the references are made up. And so this kind of gives you like an idea of some of the problems of using generative AI for research without using sort of like specialized tools that verify their answers, make sure their answers are grounded in scientific literature, and so on, like Site Assistant does. So these are like the problems we're trying to address at Site with Site Assistant. Similarly with grounded generative AI. So you might think, oh, well, if we give it a bunch of search results or access to papers, the problem is solved. So this actually touches a little bit on Simon's question, which is if you, one way to sort of think about how we could maybe solve this problem of, completely fabricating these narratives about diseases and so on. Maybe if we give it a bunch of search results from scientific literature, trustworthy, credible literature, then, for sure it won't hallucinate. And so in grounded generative AI systems, so here I'm showing Bing Bot or Bing Chat from Microsoft. The problem is improved. So this is a factually true answer. That de novo VPS4A mutations cause a multi-system disease. And it's grounded in this PubMed result, this paper that's available on PubMed, and that's great, and that's fine. However, there's like a number of issues still with grounded generative AI. So the first would be that the only kind of way we can verify this statement with the only tools that Bing is giving us to verify the statement is that it's from PubMed. And, it's sort of common knowledge that something in PubMed might be high quality, but we don't know if this paper has been retracted or withdrawn or has, significant criticisms and so on. We also don't know where in this paper or this website Bing is pulling information from to show this information, to generate that it's generating its response from. So there's quite a bit of lack of transparency with grounded generative AI systems still, so with systems like Bing or Perplexity or something like that. And again, these systems, while they are good in some respects for generating answers with search results, in other respects, I'm asking it to write an essay on the disease caused by VPS4A mutations. The essay is in line with the previous result, but there's no references here. There's no way for me to verify the claims that are being made in this generated essay. And so that's problematic for a number of reasons. Suffices to say that there's still sort of a lack of trust with systems that don't provide citations for their generated text, don't provide a transparent way for researchers to verify those. So there is also a recent study on evaluating the verifiability of these generative search engines. So, and here's, a few other systems. These are more, so the way these systems were evaluated is on more search style question answering, not scientific question answering, but this result probably generalizes to systems in grounded scientific generative AI. And so they evaluated a few systems like Bing Chat, Neve AI, Perplexity, and UChat. Now, citation recall is the number of statements the models made with no citations provided. So on average, these systems only provide citations for around 50% of the statements. Now, this may or may not be problematic. There's much of the work that we do in research writing, where we don't provide citations, and that's fine. Citation precision over on the right hand, what that means is the authors of this study had people annotate the retrieved results, the citations that were made, to check, did this citation actually support the claim that was made by the model? And on average, these models made errors 25% of the time in using citations that were completely inappropriate. In other words, there was 1 in 4 of the citations that were used did not support the claims that were being produced by the model. And so, here's kind of a summary of some of those issues. So source coverage, much of the world's scientific literature, or here, actually here's some additional kind of issues. Source coverage is a big issue. So much of the world's scientific literature is still closed access. So unless tools do have access to closed access literature like we do at Scite, then there's a lot of gaps in the kinds of responses these models can generate or citations they can cite for grounding themselves. There's big questions around how do we know whether a source is good quality or not. And then there's a bunch of verification and transparency issues. So how can we be sure that the generative AI outputs are factual? This is the thing that I just showed with citation precision, where at least on natural question answering in sort of a search setting, we see that models are still not very good at actually citing work that supports their claims. And how can we, as users, verify the outputs of generative AI? And how can systems be built in a way that makes that transparent? And finally, one kind of issue with grounded generative AI is, while they're pretty good at question answering and search and so on, what about other tasks that we might want to do? One of the things that impresses us so much with ChatGPT is the versatility on all the kinds of different tasks that it can do. So we really want a system if we are going to use generative AI for research in our research tooling and workflows, then we want systems with the same kind of versatility, where as ChatGPT, but it's verified, transparent, not fabricating references and facts and so on, and based on scientific literature. And so that's why we built Site Assistant, or we're building it, I should say. What Site Assistant? The groundwork for Site Assistant is based on Site, which is a platform that shows you everything that's been said about other papers. So basically, whenever a paper's been cited, an author says something during that citation. So we collect everything that authors have said. We show that in one single interface for people to read everything that's been said about papers. And we classify those citations as to whether they're supporting the work that they cite, contrasting it, and so on. So because of that, we have indexing agreements with most academic publishers. We use both closed and open access full text, which is over 60 million full texts. So Site Assistant can be based on full text search over all of these documents to have as much coverage as possible, including, again, to touch on Simon's question, social sciences is a big focus for us and a big area of coverage for us. Answers from Site Assistant or responses are based on papers that have been verified as supporting by others' papers. I'll show that in a minute as well. And then we've really tried to build in this notion of verification transparency. So we have an automatic verification system that ensures that there's citation precision, basically, that the papers it cites are indeed actually supporting the claim. But that's not enough, because we need to present what was used by the model to the users so they themselves can inspect and verify themselves, because these models are not perfect. If it lines up with their answer, and help them understand why that source was used and so on. And yeah, there's no fabricated citations or made up citations with Site Assistant because of that verification process. And we built it to support any kind of research task. And so Site Assistant is available at site.ai/assistant. You can try it a few different prompts without signing up for free, and that's fine. We also offer like a 7-day free trial as well. And so there's a few different examples here, but in the interest of time, because I do want to give time for questions, I'll just go over quickly what Site Assistant looks like and how it's attached to Site. So essentially, this is what Site Assistant looks like. You can ask questions. So here we have the same example I was using before. We can, we can ask a question. We can ask it to write a follow-up essay, and here, it's fully supported, unlike Bing. You can sort of hover over these citations, and you can see what was used by the model when the text was generated, and you can verify yourself why this citation supports the work that the claim that's being made by the model. And you can do other tasks, some tasks that don't require some tasks that don't require citations. So for instance, here, I asked the model to summarize the above in one sentence. So the one thing I should point out here is that one thing that we've tried to make a big part of Site Assistant is the ability to understand whether a source or reference that's being used is credible. And so because of the work we've done at Site, we show these supporting citation statements that shows whether a publication has been supported. and we allow users to go and read those supporting citations. So a user can have this experience of using Site Assistant, looking at the citations, which are ranked by not only like how relevant the citation is or the reference is, or also whether the reference does indeed support the claim made by the model, but also ranked by the credibility of the document. So how well supported it is by other papers. And so users can sort of like click that badge and get this experience of looking at how have other authors talked about this paper. And here I'm just like highlighting a supporting citation that support another paper is supporting this paper. And so there's like this chain of credibility, and you can see down below that paper was supported as well. So there's this chain of credibility that shows you that the reference used by the model is indeed credible. And these are just some more examples of more supporting citations. So I'm going to take questions now. I'll look at Simon's question in depth now. But then, I'm happy to take other questions. So we do use a number of different models under the hood, including GPT 3.5 Turbo, which is from OpenAI. That's the only one. We do use some other models from Cohere, which is another large language model company, but the rest of our models are ones that are tailored to scientific texts that are our own. And yes, the big sort of added value is that these answers are retrieved from our database, which is not more geared towards STEM or biomedicine. Actually, social sciences is a big focus for us. I would say that one sort of difference in some social sciences, but lots of humanities, is that they focus on monographs, so books. And that's not something that we do currently cover. So there is a limitation there. And then this kind of final part of Simon's question, hopefully I'm like giving a good comprehensive answer, is that we don't currently support the ability to like upload your own paper, but we will soon be supporting an ability to do that. And also you can use, you mentioned in context learning, so you can prompt the model with bits of text from your own set of papers, for instance, for asking questions and so on. Yeah.
Hi, Dom, this is Wei Fu here.
Yeah.
I have a question for you, is that we understand that Cite, you have your capability looking at citation into like 3 category: contrast, support, and mention. So how you could, or what you guys have done so far to integrate that whole analysis together with the Cite Assistant when you kind of asking a question, will that sort of quote and unquote the opinion of the different citation included in the reply when someone using the Cite Assistant?
So that's a good question. Thanks for asking that. Yeah, so there is, let me go back here. So there's a few ways that we do incorporate that. So the main way that I mentioned before is that it's really about a credibility, and it's really about a transparency experience giving to the users, or for credibility, where the users can use these supporting citations or contrasting citations to look at the credibility of a paper. Now, on top of that, yes, we do use our citation statements to pull sort of like the opinions about papers and so on when we're, and we do show that to the model. So the models can use that context if it's relevant to the question or the task of the user. So it is something that we do leverage quite a bit. and it really helps because oftentimes the citation statement is where the author makes arguments about consistent findings, replicated studies, failures of replication, criticisms about methods, and so on.
So what happened with some of the paper being retrieved? Because I know that some researchers, they reference certain paper or cite certain paper, and over time, due to whatever circumstances being retrieved. And we know that even Web of Science and Scopus at times can't even track that very well. So would that be something that picked up by site in that process?
Do you mean like do you mean whether or not, like, how easy it is to retrieve
the paper been retrieved by the someone over the time, and it still stay as a reference or citation?
I'm not sure exactly. Do you mean retracted or?
Yeah, retracted, sorry. Yeah.
Okay, retracted. Okay. So yeah, we have, as part of, there's two parts to this.
Okay.
As part of every like part where we show papers in Cite, whether it's Cite Assistant or elsewhere, we have a flag that shows whether a paper's been retracted, withdrawn, has some editorial notices like corrections or errata or something like this, and make it like very visible for users to see. But actually, unfortunately, you won't see that in the Cite Assistant because we don't show any papers that have been withdrawn or retracted. And actually, we have a paper on this that we have like our own system for mining retractions. That's like the most comprehensive, and that it's all the data is open if anyone's interested in retraction data, but like the most comprehensive like system of finding retraction. So we're like very thorough on no retracted papers are here. Of course, if you use any of these citations later on and your paper's published, something gets retracted, that happens, right? So maybe I can answer some of these, given that answers of large language models are not always reliable. Whether and how to cite them seems a concern. Any advice, or should we wait for API MLA provide guidelines? So that's a really good question. So there's only really two approaches that I've seen out in the wild, so to speak, if you are using a fragment of text from a large language model in a paper. And so the two that I've seen are actually three, I should say. One is making, the summary of this will be, wait for API MLA guidelines. Maybe I'll like order them by like most rational, which is that I think Elsevier put out a statement that their journals will accept text from GPT as long as you ensure like the quality and integrity of the text. And that's all. So you don't need to cite the text. You can incorporate it in your document without citing it. The maybe second option is you can actually cite it in the same way you would cite software or outputs of software. So there's guidelines on using corpora, basically. So references from corpora, which you could use, I've seen. The final one is people have made ChatGPT a co-author on their paper. I've seen that. That one's more extreme. Okay, so here is a question: can Cite help to summarize a group of selected publication and provide one overview? So yes, this is possible. We're still kind of working on the best way to make this the most user-friendly. So right now, you could try like putting in a list of papers, say by their titles, and ask for a summary. And that may work. You might have to email us if it doesn't, because what we want to get to is the ability for someone to select a set of papers, say by their DOIs or something like that, and provide an overview-based summary. So yeah, we're still working towards the best way to like present that to the user. It might be just inputting a list of DOIs in, or like titles in the chat. But yeah, we're still thinking about that one.
Dominic, you mentioned that, of course, for generative AI, there are certain issues needs to be addressed, for example, like factuality, etc. And I believe that site has more source, and the source of information is in more depth in comparison with other tools. But still, the text itself, when trying to answer questions, is run by generative AI. So some researchers might wonder, is there any possibility or any concern if these texts could be misinterpreted the original message? How do you see that?
Yeah, without trying to like provide too long of an answer, because it's like my active area of research at the moment. With any, as you mentioned, with any kind of generative AI model, this should always be, we should be training ourselves to be critical of their outputs, no matter how it's framed, whether it's, framed in the way I framed it, of like this experience of being transparent from credible documents and so on. It's exactly like you mentioned. We do need to be critical of their outputs. And so I'll give an illustration, which is that even for Site Assistant, so the way it works is that we provide the model with a list of retrieved results. We ask the model to sort of criticize its own answer. And we have other models that check, that verify that, this model or this piece of text from a scientific paper actually matches the response for the model. And if there's any contradictions there, we remove that part of the answer. And even after all of that, there are, because of these systems, the nature of how they're built, there are definitely opportunities where it's like you say, a scientific finding could be misinterpreted by the model. It could come out of a context that would only really be familiar to experts. And you'd only really know if you were an expert. And this has sort of like a cascading effect, because and this is like, especially I think the case with students, if you or early career researchers, if you don't quite understand yourself, the claims the model's making, and your readers are new to the claims you're making, it could be really easy to make mistakes with things that require expert knowledge. And unfortunately, there's like no easy solutions here. So even like the Site Assistant sort of setup that I provided, it's still not going to be adequate. But yeah, it's still like very much an active area of research.
Yeah, but anyway, in the end, the researchers themselves needs to take the credibility of.
Which is why we like really try to focus on building this experience of like verification for yourself, transparency, and being able to like go and look at the documents that are being cited here and really get a sense of how they're being cited and understand them deeply. And we think that kind of transparency is like, at least helps, I guess, with that. There's a hand raised.
I've Professor Noor Haslina Khalidi, I have put you in the, you are able to talk if you have any questions.
Yeah.
Okay.
No, Khalidi, you can speak now. Unmute yourself, please.
Well, maybe it was an accident. I will say though, and feel free to interrupt, Nora, if you are figuring out your microphone and you get it, that I'm gonna send these slides over so anyone can look at them. Feel free to try site.ai/assistant, and feel free to email us at support@site.ai if you have any questions, or anything's not working, or you just have, want to talk as a follow-up. So, I'd be happy to answer more questions through that way.
Right. So I think it is midnight at your end. So if there is no more questions, probably we will call it the end of the session. So any questions, feel free to write an email to Dawn or to us so that we can follow up later. But thank you all for joining us today. And we hope to see you in the next webinar. Thank you, Dawn.
Thank you, Tom.
Everyone.
Goodbye.
Goodbye.
Thank you. Bye.